Hello everybody and welcome back to another math learning video. Today I brought you guys this geometry problem here where we are supposed to find this value of x which represents the side length of the square here, okay? So we need to find the side length of the square, and inside the square we have a triangle with side lengths of 3, 4, and 5. So let's go ahead and solve for x. So first thing I'm going to look at is I'm going to look at the triangle in the inside. So it has side lengths of 3, 4, and 5. So do these values bring anything to mind to you? 3, 4, and 5? Well, let's remember. You guys are familiar with the Pythagorean theorem, right? That states that in a right triangle, the Pythagorean theorem states that in a right triangle, the side lengths of the right triangle will conform to the equation a squared plus b squared equals c squared, okay? So why did I bring this up? Well, because I brought this up because the values of 3, 4, and 5 are a common right triangle or common Pythagorean theorem combination. Because look, if we were to have our 3 and 4 and our 5 is our hypotenuse, this would be 3 squared plus 4 squared is equal to 5 squared. So 9 plus 16 is equal to 25. And this is a true statement, right? So what does this mean? Well, since this triangle conforms to the Pythagorean theorem, this means that this triangle is a right triangle, okay? So that means that in a right triangle, this angle here is equal to 90 degrees, okay? So we figured that out. What does that help us? Because we still don't know these angles, and this angle is not even part of the square. So let's see. So now let's look at the triangles that are related to the square side length. So this triangle here. So for now, I'm going to call this angle here. I don't know what it is. I'm going to just call it alpha, okay? So then, since this also is a right triangle, this triangle, because a square has 4 degrees of 90 degrees, 4 sides of 90 degrees. We can see here it's a right angle. So since this is a right triangle, all angles in any triangle have to add to 180, right? So since this angle is equal to 90, these two angles have to also equal to 90. So this, if this angle is alpha, then this angle is 90 minus alpha, right? So now we got the values for this triangle here. Now let's look in this triangle. Let's see, this triangle kind of looks similar to this triangle, but we need to be able to prove that. And how can we prove that? We can prove that by showing that all the angles are the same value, right? So if the corresponding angles are the same, then it is a similar triangle, which means it has the exact same shape, but the size may be different, but then the size would be proportional. Each side length would be proportional to one another. So, but we first need to prove that. So 90 degrees, both angles have, which is good. This angle here would have to be equal to alpha, right? If this were to be true. But how do I prove this? Well, we know that a straight line from here, this straight line is equal to 180 degrees, right? And since we know that these two angle values, we know this angle value here is equal to 90, and this angle value here is equal to 90 minus alpha. That means that the remaining must be 180 minus 90 minus 90 minus alpha, okay? So we have 180 minus 90 here, and then minus, make sure to put parentheses here, 90 minus alpha. So this will give us totally 180 minus 90 minus 90 plus alpha, okay? Because in the parentheses, these two negatives makes a plus. So now we have 180 minus 90 minus 90. So negative 90 minus 90 is equal to 180, right? So 180 minus 180, they simply all cancel each other out. We are simply left with alpha. So if we have proved that this side length is alpha, so since these two side lengths are the same, the last side length have to be the same since they both equal up to 180. So this side length is equal to 90 minus alpha also. And now these side lengths here are proportional to one another, okay? This means that we can create a proportion. We need to set up ratios of the same side length. So here, this is the hypotenuse of this right triangle, and this is the hypotenuse of this one. So 4 is equal to 3, but now we need a ratio of something. So this ratio, we want to include the value that we're looking for, x, right? So this 4 over x, this ratio is equal to 3 over something. But what will that something be here? So since we don't know this value yet here, we don't have anything, I'm going to call this value here y, okay? If this value here is y, that means that this value here, because the whole side length is equal to x, remember, would be x minus y. So that means that for our ratio, I'm going to put this base value, under 3 as x minus y, okay? So now we're going to do some algebra in order to solve for x. So I'm going to multiply both sides by x first. And now we multiply both sides by x minus y to get it out of the denominator. So then we get 4x minus 4y is equal to 3x, okay? So now let's try to solve for x. So if you subtract 3x from both sides and add 4y, these two cancel out. And then we get x is equal to 4y, right? So now if we solve for y, we can also solve for x. So how will we solve for y? Well, we can use this smaller triangle here and use Pythagorean theorem, right? Since we only have one variable and we have an equation to solve. So we have that, the base squared. So 4y squared plus y squared is equal to 4 squared, right? So that gives us 4y. So when you square a term that has a variable and a coefficient, we square both of them, okay? So this will turn into 16y squared plus y squared is equal to 16. So these two have the same terms, y squared. So this will be 17y squared is equal to 16. So y, if we want to solve for y, is we subdivide by 17. So we get that y squared is equal to 16 over 17. And then we square root. So if we square a fraction, we can square both the numerator and the denominator. So we get that y is equal to square root of 16, which is equal to 4 over square root of 17, which we cannot simplify for now, okay? But since we don't like to have coefficients in our denominator, let me go ahead and make it a little cleaner. So I'll just multiply both sides by square root of 17 to get the square root out of the denominator. So we get that y is equal to 4 times square root of 17 over 17, okay? And since x is equal to 4 times y, that means we can simply multiply this value by 4. So x is equal to 4 times square root of 17 over 17. So this means that our final value of x is equal to 16 square root of 17 over 17. And that is our final value. Okay, so we solved this problem. So thank you for watching this video. I hope you enjoyed it and see you guys next time. Bye.